All right, so today we're diving deep into the world of aluminum.
Aluminum, huh? Sounds kind of mundane, right?
Well, that's what I thought at first. But then I started digging into the research for this deep dive, and let me tell you, it's way more interesting than it gets credit for.
I'm intrigued. Lay it on me.
Okay, so first of all, it's everywhere.
Everywhere.
Like literally the most abundant metal in the Earth's crust.
Ah,
But here's the thing.
hit me with a plot twist.
You almost never see it in its pure form. It's always bound to something else.
So that's why we don't just trip over bars of aluminum on our morning jog, right?
Exactly. The article, Aluminium Element Information, Properties and Uses, it was talking about how it mainly exists as an oxide. Like bauxite, ever heard of it?
Bauxite rings a bell, but I couldn't tell you what it looks like if my life depended on it.
Me neither. But apparently that's what we dig up to get our aluminum. Wild, right?
So no shiny veins of aluminum or just waiting to be collected. It's all about chemical extraction then.
Pretty much.
Yeah.
And that's where things get really interesting. Get this. Archaeologists found this ornament, right, in the tomb of a Chinese military leader from the 3rd century.
Okay, that's pretty cool already. Ancient tombs, always good for a story. What was the ornament made of?
85% aluminum.
Hold up, 3rd century. And it was that pure. How is that even possible?
Like the technology to do that back then, it's mind-blowing.
It really makes you wonder about what those ancient civilizations were capable of.
Seriously, did they stumble on some naturally pure aluminum deposit? Or did they have some crazy advanced metallurgical secrets that are totally lost to us now?
It's a total mystery, and it kind of puts our own technological progress in perspective, doesn't it?
Totally. But speaking of aluminum's properties, this whole ancient ornament thing, it kind of highlights one of the things that makes aluminum so useful, even today. Its resistance to corrosion.
Right. That thin oxide layer, it forms, it's like its own little suit of armor, protecting it from the elements.
Yeah, and it's been doing that for centuries, apparently. But here's the kicker.
Don't leave me hanging.
Even though people had been finding aluminum in one form or another for ages, it wasn't until the 1800s that we figured out how to actually isolate it and produce it on a large scale.
Right. There was that whole period where aluminum was more valuable than gold, if you can believe it. The article mentions Napoleon having a set of aluminum plates that he'd only use for his favorite guests.
Talk about a power move. Only the most honored get the aluminum tableware, people. But seriously, what changed? Why the sudden leap in aluminum production?
2 words. Hall-Héroult.
Hall-Héroult.
Yeah, the Hall-Héroult process, it was a game changer. Before that, aluminum was incredibly difficult and expensive to produce.
So what did this Hall-Héroult process do differently? What was their secret sauce?
Electrolysis. They figured out a way to use electricity to extract the aluminum from its oxide.
Electrolysis. So basically, using electricity to drive a chemical reaction. Sounds kind of modern.
It does, doesn't it? But the concept of electrolysis itself has been around for quite a while. The real breakthrough was figuring out how to apply it to aluminum production.
Okay, I'm following. So how does that actually work?
They discovered that you could dissolve alumina, which is aluminum oxide, in molten cryolite.
Cryolite. Got it.
And here's the cool part. Cryolite has a much lower melting point than pure alumina.
So less energy needed to melt it, right?
Exactly. Much more efficient. Then they run an electric current through this molten mixture, and bam, the aluminum separates from the oxygen and you collect it.
Whoa. It's like magic, but with more science.
Exactly. It's a really elegant solution to a previously very challenging problem.
It's amazing how something that seems so straightforward, getting aluminum from the ground, actually involves all this intricate chemistry and ingenuity.
Right. It makes you appreciate the complexity behind even the most everyday materials.
Totally. But going back to the whole process for a minute, the article also mentioned something called the Bayer process. What's that all about? Is that part of this whole electrolysis thing?
Good catch. It's actually a separate step, but it's crucial. The Bayer process is what's used to purify the bauxite ore into alumina before it even gets to the Hall-Héroult stage.
So 2-step purification process. First, you get rid of all the junk in the bauxite to get to the good stuff, the alumina, and then you hit it with the Hall-Héroult to separate the aluminum from the oxygen.
Precisely. The Bayer process itself is a whole other can of worms involving high pressure, high temperatures, and a bunch of chemical reactions to isolate the aluminum-bearing minerals.
Sounds complicated. But essential, clearly, if we're talking about producing aluminum on a massive scale.
Absolutely. Without the Bayer process, we'd be stuck with impure aluminum oxide, and that wouldn't get us very far.
It's crazy to think about how aluminum production went from this small-scale, almost like artisanal process to a full-blown industrial operation in such a short amount of time.
It's a classic example of how technological advancements can completely revolutionize an industry.
And completely change the value of a material, too. Remember we were talking about aluminum being more expensive than gold?
Yeah, it's amazing how something that was once reserved for royalty is now found in, like, every kitchen cabinet on the planet.
Talk about a glow up. But seriously, it just goes to show how much our perception of value is tied to our ability to actually get our hands on something. But it still blows my mind that 85% pure aluminum ornament from that ancient tomb.
I know, it's like a giant question mark hanging over everything we think we know about ancient technology.
Right. It makes you wonder what other secrets are still out there just waiting to be rediscovered.
There's always more to learn. That's what makes all this so fascinating.
Absolutely. But for now, let's shift gears a bit and talk about what happened once aluminum did become widely available. What did we do with all of it? Well, once aluminum went mainstream, it kind of took over the world, didn't it?
It did. The article points out it's everywhere now. Buildings, cars, even the packaging for our food. It's kind of amazing when you think about it.
Right, we take it for granted, but it really is a pretty remarkable metal when you get down to it.
Totally. Lightweight, but you can alloy it to make it crazy strong. Plus, that whole corrosion resistance thing we were talking about, it's like the Energizer Bunny of metals. And did you know it's also an excellent conductor?
For both heat and electricity, if I'm remembering the article correctly, right?
You got it. It's a pretty versatile element.
Which explains why it's used in so many different things, I guess. But that brings up something I was thinking about. With all this aluminum surrounding us, should we be concerned about any potential downsides?
That's a good question, and the Wikipedia article did mention some concerns about toxicity. But the good news is that for most people, everyday exposure to aluminum isn't considered a major health risk.
So need to freak out and toss out all my aluminum cookware just yet.
Not unless you were planning on melting it down and drinking it, no. But seriously, the levels most of us encounter are well below anything to worry about.
Okay, that's reassuring.
Of course, it's always a good idea to stay informed, right? Research is ongoing, and our understanding of these things is always evolving. For example, they're still looking into the potential link between aluminum and Alzheimer's disease.
Right, right.
But for now, I think it's safe to say a little aluminum foil in your life isn't going to hurt you.
Good to know. But what about the environmental impact of all this aluminum production? We talked about those processes, the Bayer and the Hall-Héroult. They don't exactly sound eco-friendly.
Yeah, you're right. Extracting aluminum from bauxite takes a good chunk of energy, which translates into greenhouse gas emissions.
And then there's the mining itself, which can't be great for the environment either.
Definitely not. The article touched on the deforestation and habitat loss associated with bauxite mining. Plus, there's always the risk of contaminating the soil and water if things aren't managed responsibly.
So it's kind of a trade-off then. Aluminum has all these amazing properties, and it's revolutionized so many industries, but not without a cost.
Exactly. It's a good reminder that everything we do has an impact. It all comes down to finding ways to minimize that impact and make more sustainable choices.
Which brings us to recycling, right? Isn't aluminum infinitely recyclable?
It is, and that's huge for reducing its environmental footprint.
Because if we can recycle it, we don't have to mine as much bauxite, which means less energy used and fewer emissions, right?
Exactly. Recycling aluminum uses a fraction of the energy compared to producing it from scratch.
So it sounds like while the production of aluminum definitely has its downsides, being mindful about how much we consume and making sure we recycle it properly can go a long way in mitigating those negative impacts.
Absolutely. It's all about making conscious choices, right? And thinking about the entire life cycle of the materials we use.
Totally. It's pretty amazing when you think about it. This one metal aluminum and how much we've learned about it just in this deep dive alone.
Right. Talk about a deep dive. We've gone from ancient tombs and Napoleon's dinner parties all the way to electrolysis and global industry.
And somewhere in there, we even managed to squeeze in a little linguistics lesson.
Oh, yeah. Speaking of which, we never really settled that whole aluminum versus aluminium debate, did we?
We didn't. And you know what I kind of like that we left it open-ended? It's a good reminder that even in science, things aren't always black and white.
Exactly. Even IUPAC, with all their rules and regulations, had to acknowledge that language is fluid.
Right, like Humphrey Davy, the guy who first isolated aluminum.
He went with aluminum, right?
Yep. Which honestly makes perfect sense if you think about how other elements were named back then. But then IUPAC swoops in with aluminium.
citing the Latin root alumen for their reasoning, as I recall.
Exactly. But here's the funny part. Even though they declared aluminium the official spelling, they still acknowledged aluminum as an acceptable variant, particularly in American English.
They couldn't fight the tide of common usage, even if they wanted to.
It's a good thing they didn't try. Can you imagine the chaos? Every chemistry textbook would have a disclaimer.
Right. The following words are spelled differently depending on what side of the Atlantic you're on.
It would be a nightmare. But seriously, it's a good reminder that language is constantly evolving, even the language of science.
Absolutely. It's a living thing, constantly being shaped by the people who use it.
Well said. So I guess what we're saying is, whether you say aluminum or aluminium.
You're still talking about the same amazing metal.
Exactly. The
Yeah.
one that's in our soda cans and our airplanes.
And maybe even in an 1800-year-old Chinese ornament, if we're lucky enough to find one.
Don't forget Napoleon's fancy plates.
Yeah.
Okay, but in all seriousness, we've covered a lot of ground in this deep dive.
We have. From the depths of the earth to the heights of modern technology and everything in between.
We've explored its properties, its history, its impact on the environment. We even got a little philosophical about the nature of language.
It's been quite a journey.
It has. And I hope our listeners enjoyed the ride.
Me too. Who knew there was so much to say about aluminum, right?
Right. It just goes to show that sometimes the most ordinary things have the most extraordinary stories to tell. You just have to know where to look.
And be curious enough to start digging.
Exactly. And on that note, I think we're ready to wrap up this deep dive. Thanks for joining us today.
Until next time.